Given a function, a polynomial function, that has a given 0, find the remaining zeros, real zeros, using synthetic division and factor the polynomial completely. So we want to find the remaining zeros and factor the polynomial completely. We have 1 0, x equals 4. It's a degree 3 polynomial, so it has potentially 3 zeros. So the remaining real zeros, we might have 2 answers, might only be 1, might not be any. Let's find out. So with synthetic division, if we set up our synthetic division, our coefficients 1 x cubed minus 8 x squared, 19 x, and constant negative 12, no placeholder was needed, and x equals 4, the 0 is the value that we use in the synthetic division. We bring the 1 down. 4 times 1 is 4. Negative 8 plus 4 is negative 4. 4 times negative 4 is negative 16. 19 minus 16 is 3. And 4 times 3 is 12. Negative 12 plus 12 is 0. This should not be a surprise. Remainder 0 happens if you're working with a 0, which they said it was a 0. So this is perfect. What this gives us, though, is the remaining stuff, the x squared minus 4x minus plus 3. This is the remaining piece of this polynomial after we remove the x minus 4 factor. We can factor this. We could also use the quadratic formula if needed. This is x minus 3 times x minus 1. So that means the remaining zeros are 1 and 3. We can see them in factored form. So that's the first part of the answer. And now sometimes they say find all real zeros, then we include the 4 in the list. But in this case they said find the remaining real zeros, so we don't need to include the 4 because that wasn't one of them that was remaining. That was the given one. Factored form, we have 2 of the factors, so let's call this f of x equals, we have x minus 3 and x minus 1, and the original 0 in factored form would be x minus 4. So our completely factored polynomials, x minus 3 times x minus 1 times x minus 4, the order of those factors is irrelevant. Just make sure you have all 3. And because the coefficient, the original coefficient, the x cubed is 1x cubed, then we want to make sure we have the same coefficient for this one. You don't see it, but I wanted to mention that it is a coefficient of 1. All right, that is the second part of our answer.